Hello everyone, welcome back to TechOps tutorial. In today's video, we are diving into one of the most important topics in Kubernetes, persistent volume and persistent volume claims. If you haven't watched my previous video where I have explained the theory behind PV and PVC, I highly recommend checking that out first. You will find the link in the description and also in the card above. So what's the problem we are solving here? Well, pod in Kubernetes are temporary. If a pod is deleted, any data inside will be lost. But what if your application needs data that survives pod restart? That's where PV and PVCs comes in. In this demo, I will show you step by step how to start Minikube on Rocky Linux, create a persistent volume, bind it to a PVC, mount it in a pod, test the persistent, and finally see how Kubernetes handles cleanup with reclaim policies. By the end of this video, you will have a solid hands-on understanding of how Kubernetes manages the storage. So let's get started. For this demo, I will be using Minikube running on Rocky Linux with a Docker driver. This is the local setup, not on any cloud platform. Starting Minikube, make sure we have a fresh single node Kubernetes cluster for our demo. So let's start the Minikube. First, I am starting Minikube with a Docker driver. This gives us a single node Kubernetes cluster to run our demo on. This will take a minute to start Minikube. Okay, Minikube is started. Let's check the status. So let's clean up. So we will clean up everything to avoid the conflicts. Run kubectl delete all, and I will mention -all. Everything we will delete. We will not keep anything. Once this is deleted, we need to delete PVC and PV as well. As you can see, it is not deleted. Okay, everything is deleted now. Let's delete kubectl delete PVC -all. I will mention delete from all namespaces. If you have created the namespaces, it will delete from there. There is no resource found. So let's delete kubectl delete PV -all. No resource found. First, let's make sure we start with a clean Kubernetes environment. So kubectl delete all -all removes the pod, service and deployment, but it does not delete the persistent volume or a persistent volume claims. That's why we explicitly remove them too. This way no old resource interfere with our demo. Since we are learning, it's safe to clear everything before we start. This way no old pods, service or configs interfere with our demo. After cleanup, we will check that our Minikube node is ready and no pods are running. Check the nodes. Now check the pod. Okay, let's make sure our cluster is running fine. Here we can see my Minikube node is ready and no pods are running yet. These are the system pods. We can ignore this. So let's create a persistent volume. A PV is a storage provisioned by an admin. Think of it like a disk where we are making available to the Kubernetes. So I will create a YAML file first, pv.yaml. We'll mention API version v1, kind. Here we will mention persistent, volume, metadata. We will give demo -pv. Let's add the specification. Capacity I will give storage (1 GB). Access mode read write once. Host path will give the path /mnt/data. Persistent volume reclaim policy retain. Let's save it. kubectl apply -f pv.yaml. Cannot be handled as a persistent volume strict. Let's check what else is wrong here. Persistent, there was a typo mistake. Volume reclaim policy retain. Unknown field. Okay, this is created now. Let's see kubectl get PV. Here I created a PV of 1 GB using the host path. Notice the reclaim policy is set to retain, meaning Kubernetes won't delete the data even if we delete the claim later. So next, create a persistent volume claim. PVC is how user requests the storage. Kubernetes matches the PVC to an available PV. So let's create PVC. I will create a YAML file for that. API version v1. Persistent volume claim. Next is metadata. suffix. Access mode we will give hyphen read write once resource and then request and storage 1GI. kubectl apply -f PVC YAML. So here I created PVC requesting 1 GB. Let's mount PVC in a pod and write the data. Before that I forgot to show you kubectl get PVC. The status, it is showing pending. Okay, I just created my persistent volume and persistent volume claim, but notice something here. As you can see, the PVC is stuck in pending state. This usually happens when the Kubernetes cannot find a matching persistent volume. In our case, the problem is that my persistent volume does not have the storage class, but the PVC by default is trying to use the standard storage class. So let's fix it by explicitly setting the storage class name to an empty string in our PVC. This way Kubernetes will directly bind it to a static PV. So let's update the YAML. Here we'll add storage class name as a empty. Now I will reapply it. So when I try to reapply my PVC with storage class name set to empty, Kubernetes threw this error saying the specification is immutable. That's expected behavior. Once a PVC is created, you cannot modify certain fields like storage class. The solution is to delete the old claim and create a fresh one. So the command is kubectl delete PVC demo hyphen. So this is deleted now. Now let's reapply it. Let's check again. Perfect. Now the PVC is successfully bound to our persistent volume. The status is changed from pending to bound. Let's mount PVC in a pod and write a data. I will create pod.yaml API version equals to v1, kind will be pod, metadata name will be demo pod, specification container, we will use image as a busy box and we'll add one command -c, we'll add sleep 3600 and volume unts mounts. /data. Here we'll give name as storage. Demo PVC. Save the file. Cannot be handled as a pod, no kind pod. Pod P capital. This is created. Let's log into the pod. exe -it. You need to give a pod name. So we'll enter some text. Hello from PV. So our pod is now using the PVC. Inside it, I wrote some data into the mounted directory. This data lives on the PV, not the pod itself. Exit kubectl. Now what we will do, we will delete the pod and verify if the data persists. Kubectl delete kubectl get pods, kubectl delete pod demo pod. The pod is deleted. kubectl get pods. The status is terminating. Okay, pod is deleted. It takes some time to delete. So what we will do, we will apply it once again, the YAML file of pod. We reapplied the pod. Kubectl get pods. Here you can see there is no any pod. Now you can see the pod. The pod is running. 9 seconds ago it is created. So let's log in. Kubectl exe -it. Give the pod name. You are inside the pod. Let's check if we have the data. Even though I deleted the pod, when I recreated it and checked the file, the data was still there. That's the power of persistent volumes. Now let's delete the PVC and test a reclaim policy. Kubectl delete. Let's check first. Kubectl get pods. Kubectl get PVC. Now let's delete it. Kubectl delete PVC. This is taking time. Here you can see the status is terminating state. This will take some time to delete. Let's recheck once again. Still it is showing terminating. Let's run once again. PVC is stuck in terminating state. This usually happens when Kubernetes has added a finalizer for protection and it does not allow PVC to delete automatically. So let's check first. Here you can see in a metadata there is a field called finalizer with a kubernetes.io/pvc-protection. This is what blocking the deletion. So to fix this, I will patch the PVC and remove the finalizer. Metadata. Now let's delete the PVC again and check if it is gone. Oh, it is already deleted after we have patched. So let's understand what actually happened. If your PVC ever gets stuck in terminating state, the common reason is that the PVC-protection finalizer. By removing that finalizer and forcing deletion, you can clean up the PVC safely, especially in test or demo environments. Now let's check the PV. The status is changed to released. Now I deleted the PVC. Notice the PV did not disappear, but its status changed to released. Since our reclaim policy is retained, Kubernetes kept the underlying data. So let's see demo on how to change the reclaim policy and observe the cleanup. kubectl. For this as well, I will do the patch demo-pv. Reclaim policy I will set to delete. Earlier it was retain. So this has been patched. Let's see kubectl delete pvc demo-pvc not found pv sorry, not delete, get pv. As you can see, even though my PVC is gone, the PV is stuck in failed status. Notice it still show claim default/demo-PVC, which is no longer exist. That's why Kubernetes cannot clean it up automatically. To fix this, we need to remove that reclaim reference manually. kubectl edit PV demo-PV. In the editor, go to spec.claimref. Inspect claimref. This is the claim reference section, and delete the entire block. Once that removed, save and exit. Now let's check the PV again. You can see PV is no longer bounded, and it's also available to be reused or deleted. If you don't need this PV anymore, you can delete it with kubectl delete PV demo-PV. So the key learning here is, if the PVC gets stuck, remove the PVC protection finalizer. If the PV gets stuck in failed state, clear out the old claim reference and then delete or reuse it. Alright, let's quickly recap what we did in this demo. We started Minikube on Rocky Linux, cleaned up everything, means cleaned up the environment and verified our cluster. Then we created a persistent volume, bound it with persistent volume claim and mounted it inside a pod. We tested the data persistent by writing some data, deleted the pod and confirms our data was still there. Finally, we deleted the PVC, switched the reclaim policy to delete, and observed how Kubernetes cleaned up the persistent volume automatically. And that's it for this demo. You now have a solid understanding of how persistent volume and claims works in Kubernetes along with the reclaim policies. If you found this helpful, don't forget to hit the like button, subscribe and share this video with others who are learning the Kubernetes. In upcoming videos, we will dive into more Kubernetes concept and real world demo. So stay tuned. Thanks for watching. I will see you in the next tutorial.